Previously, we discussed the sampling distributions for proportions, and now we're moving on to the sampling distribution for means. And so instead of going back through the definition, right away we know that the population mean is represented by mu. And so when we estimate this value, our sample mean or point estimate is always given by x bar. And so in this video, we need to go over new assumptions when going through inference about means, and we're going to learn how to describe this distribution theoretically. So first of all, there are two assumptions that you need to follow and check for anytime you're doing inference. And first, you always need to check that you have a simple random sample. Then you need to check the central limit theorem, and previously we did this for proportions, but this theorem changes when you're discussing means. And so in the problem, if it tells you that the data is normally distributed, then there's no need for the central limit theorem. However, if you have a very skewed distribution, you need to have a sample size that's greater than or equal to 40. If the question does not specify the distribution, then you just need to check that the sample size is greater than or equal to 15. And so once you check your assumptions, you do need to check them before describing the sampling distribution. But when we describe it, we're going to use the same notation as we did for proportions, except now we're going to state that x bar is distributed normally with a mean of mu and a standard deviation of sigma over the square root of n. And so here we're going to use the population mean when describing the distribution. And the big difference is that when you have a sample mean, you need to divide the standard deviation by the square root of the sample size. So when you describe x bar, you now have the center and the spread covered, and because it's normally distributed, you're covering the shape and the unusual features. So this is all you need to describe the distribution. And one thing to note, there is no calculator method for this problem, so anytime you describe the distribution, you just need to use the formulas to plug in your mean and standard deviation.